Hello, welcome to the Mark Janard Show, the cybersecurity show. In this video, I'm going to give an in-depth overview of what large language models are. This is basically an intro, right? So that we can both understand what they are and why they matter in the first place. So without further ado, let's get right into it. We're going dark. So how do large language models differ from traditional language models? Large language models, LLMs, that's what I'm going to call them, differ significantly from traditional language models in several key aspects. We have architecture and scale. LLMs are built on advanced neural network architectures, typically using transformer models with self-attention mechanisms. This allows them to capture complex contextual relationships between words across long sequences of text. In contrast, traditional language models often relied on simpler statistical methods like n-grams or hidden Markov models, which had limited context windows. LLMs are also much larger in scale, with models like GPT-3 containing hundreds of billions of parameters compared to traditional models that were orders of magnitude smaller. Next, we have the training, data, and approach, right? LLMs are trained on massive data sets, often comprising hundreds of gigabytes or even terabytes of text from diverse sources. Please take a moment to hit that subscribe button and the like button. Hit that subscribe button and the like button right now. So this allows them to learn a broad understanding of language and knowledge. Traditional models were typically trained on much smaller, more specialized data sets. LLMs use unsupervised pre-training on large corpora, followed by fine-tuning for specific tasks. This transfer learning approach differs from traditional models that were often trained from scratch for individual tasks. Now, the next one we have is capabilities and performance. So LLMs demonstrate significantly improved performance across a wide range of language tasks, including more natural and coherent text generation, better understanding of context and nuance, the ability to perform multiple tasks without explicit training, right? Few shot learning, improved performance in translation, summarization, and question answering. Traditional models were generally more limited in scope and struggled with tasks requiring deeper language understanding or generation of longer, coherent text. The next one we have is flexibility and generalization, right? LLMs exhibit strong generalization capabilities, allowing them to adapt to new tasks with minimal additional training. They can often perform well on tasks they weren't explicitly trained for. Traditional models typically require separate training for each specific task or domain. Resource requirements, right? LLMs require substantial computational resources for training and inference, often necessitating power GPU clusters. Traditional models were generally less resource intensive and could run on more modest hardware. Now, there are some challenges, right? While LLMs offer significant advantages, they also face unique challenges, right? What are those challenges? I got you. It's right here. Potential for generating biased or inappropriate content, difficulty in interpreting their decision-making process, high computational and energy costs, ethical concerns regarding their use, and potential misuse. So, to summarize how they differ, right? LLMs represent a significant leap forward in language modeling capabilities, offering more sophisticated language understanding and generation across a broader range of tasks, right? But also introducing new challenges and considerations in their development and applications. Now, let's get into the meat and potatoes, right? What are language models? We talked about how they differ, but really what they are, right? Large language models are advanced artificial intelligence systems trained on vast amounts of text data to understand and generate human-like text. So, LLMs are machine learning models designed to process and generate natural language at scale. They consist of two main components. Number one, you have the large file of parameters, that's the weights, learned during training. Number two, you have a smaller code file to run inference using those parameters. So for example, Meta's Llama model has a 140 gigabyte parameter file and a 500 line C code, run file. So here is how LLMs work. LLMs use neural network architectures, typically based on transformers, to predict the probability of words or tokens in a sequence. This allows them to complete sentences and generate text, answer questions, translate languages, summarize content, perform other language-related tasks, training process, right? Now, training an LLM involves, right, collecting a large corpus of text data, that's like the 10 terabytes of, from web crawls, using powerful GPU clusters to process and compress this data, optimizing model parameters over many iterations. Now, this process can take weeks and cost millions of dollars for large models. Now, there are some key capabilities that I'm about to discuss right now. Modern LLMs exhibit impressive abilities, including natural language understanding and generation, task performance across various domains without explicit training, tool use, right? That's, web browsing, calculations, etc. And then you have the multimodal processing. That's the text, the images, the audio, right? Now, applications. LLMs power many AI applications like chatbots and virtual assistants, content generation, language translation. What language do you think that it will be best suited to translate? Please let me know in the comment section below. Text summarization now, and question answering systems. So there are some ongoing developments. The field of LLMs is rapidly evolving, with research focused on scaling to even larger models, improving efficiency and reducing computational costs, enhancing reasoning capabilities, addressing security and ethical concerns. So, as LLMs continue to advance, they are likely to have a transformative impact across many industries and applications. What are those industries? Tech industry, obviously, right? So, however, it is important to be aware of their limitations and potential risks as these technology develops. So, how do LLMs impact the job market and employment, right? Large language models are poised to have a significant impact on the job market and employment. Now, about 80% of the US workforce could have at least 10% of their work tasks affected by LLMs, while approximately 19% of workers may see at least 50% of their tasks completed or impacted, right? This indicates that the effects of LLMs will be felt across a wide range of occupations and industries, okay? Now, it's not only that, there are higher skilled jobs that may be even more affected, right? Contrary to previous technological disruption, LLMs are likely to have a greater impact on higher skilled and higher paying jobs. Workers with more education and training, including those with bachelor's, master's, and professional degrees, are more exposed to LLM automation than those without higher educational credentials. Specific occupations at risk, you have writing and programming related jobs are among the most at risk of being impacted by LLMs. The study also found that scientists, researchers, and technologists are among the job groups most exposed to LLM effects. Okay, so that's what I have for you today. Please take a moment to hit that subscribe button and the like button. Please take a moment to hit that subscribe button and the like button. I appreciate your viewership. Stay safe and see you on the next video.